All right, so it says two astronauts have a mass of 62 kilograms and are floating motionless in space at a distance of 5 meters apart from each other. How much gravitational force does each astronaut exert on one another? So this is an interesting one. Let me sketch the picture for you. So you got some guy out here in space, just kind of floating along. And you got some guy out here in space, just kind of floating along. This guy has a mass, we'll call him M1, has a mass of 62 kilograms. That's what we want. We want it in kilograms. This guy over here has a mass, we'll call his mass M2, also 62 kilograms. What are the odds? And the distance between them is 5 meters. So remember that to find the gravitational force, and they're saying in space, which means that Earth has no impact. The Earth's gravitational pull has no impact on them. So the formula that you use to calculate gravitational force between two objects is this one right here. We say that the force of gravity is equal to the gravitational constant times the mass of the first object times the mass of the second object, all over the radius or distance between the two. So this is R. Okay. And then we plug that in. Now remember that the gravitational constant, well, let me write this down. Capital G, gravitational constant for gravity, is 6.6 times 10 to the negative 11. And the units are a little wonky. It's Newton meters squared over kilograms squared. So I'm going to say 6.67 times 10 to the negative 11 times the mass of the first person, which is 62, times the mass of the second person, which is also 62. All and it's 5 meters apart, so divided by 5 squared, which is 25. So now for this, I'm going to pull up my fancy Desmos calculator somewhere. Give me a second. This you can literally just plug into your Desmos calculator in one swoop and get it all done. Let me move this over here. So to do that, I'm just going to plug in. I'm going to hit this fraction button. Let me move my face. I'm going to hit this fraction button, and I'm just going to say 6.67 times 10 raised to the negative 11. And then I got to get this right arrow because I don't want everything up here. So I'm going to say times 62 times 62, and then in the bottom I'm just going to say 5 squared. Hit enter. I get we'll round that to 1.3 times 10 to the 8th newtons. So let me minimize this. Oh shoot. .03 times 10 to the negative 8. And that's in newtons, of course. Any questions on that? Now, I'm going to give you a little clue. That seems like a pretty easy problem to do. You're going to need to make sure you have this formula. Now, we wrote it down in class. We've done 1 or 2 problems on it. I don't know if you guys have had enough practice with it, though, because it seems like all the questions that we've done on this last practice test have been regarding this gravitational force. Remember, there's 2 ways to calculate the gravitational force. Remember, force is mass times the acceleration. So if something's in free fall, it's always the mass times g. But if it's 2 objects, that's the gravitational force of just one object. Well, there's two scenarios. If something's in free fall, it's usually mg. That's the force due to gravity going down towards the center of the Earth. But if it's two objects and you're trying to figure out the gravitational force between the two, you'd probably use this equation. Okay? And you would know because if they give you the mass of two objects, this is the one you need. Okay? Which one was that? Number 13, you said?